Hello engineers, today we will see how to select cooling fan for indoor enclosures. Step 1 is to calculate internal heat load. Power loss of electrical components inside the control panel emits heat. Our cooling system should be capable of removing this heat. Internal heat load can be calculated by adding the maximum heat output for each device installed in the enclosure. Let us consider our control panel have below listed components. We can find heat loss of each component from technical specification. If heat loss is not mentioned in data sheet, we can still find heat loss. In that case, check efficiency of component. Suppose one of the 500 watt component has 97% efficiency, then its heat loss would be 3% of 500 watts, that is 15 watts. After getting heat load of all component, add them. For our example, total heat loss would be 413.46. All the data sheets of listed components can be found on link mentioned in description. Step 2 is to calculate surface area of enclosure. Please note panel can have 6 surfaces: front, back, top, bottom, right and left. We have to eliminate the surfaces which are against the wall or bottom, as they will be rejecting heat from adjacent surfaces. Some common scenarios for excluding those areas are listed. For our example, we will consider freestanding enclosure. Surface area will be 17 square feet. Our next step is to decide heat transfer coefficient K. It depends on the enclosure material. You can refer this table to get the value of K. For our example, let us consider material of enclosure is painted carbon steel. So our K will be 0.97. Step 4 is to calculate delta T. It can be calculated by subtracting maximum allowable enclosure temperature TE from ambient temperature TA. Choose the component value with the lowest maximum operating temperature as TE, otherwise recommended TE is 35 degrees Celsius, that is 95 Fahrenheit. For our example, we will consider ambient temperature as 86 Fahrenheit, that is 30 degrees Celsius, and desirable enclosure temperature as 95 Fahrenheit, that is 35 degrees Celsius. So our delta T will be -9 Fahrenheit. Step 5 is to calculate heat transfer load. We have already calculated the values of K, area and delta T. Just multiply these values to get heat transfer load. Step 6 is to calculate required cooling capacity. Just add internal heat loss, which we have calculated in Step 1, and heat transfer load. Step 7 is to calculate required air flow. Formula is shown in video. Insert the values of required cooling capacity Q, R and delta T to get the CFM. We get CFM as 93. We are taking 20% safety factor here. Safety factor depends on how conservatively you want to design. With 20% safety factor, we get required CFM as 112. We can check fan data sheets to select the model number. For example, refer shown EBM PAPS data sheet. We can select marked model numbers, as our CFM requirement of 112 will be fulfilled. One more data sheet is shown for your reference. Make of the fan is Sunan. Model numbers are marked to meet 112 CFM requirement. All the data sheets of listed components can be found on link mentioned in description.